Hey guys, so we're going to take a different tact on this one. Let me look at some definitions first of what we're going to see when we hit 8.1. First, there's a population. It's a particular group of interest in a study. Next, we have data. That's the information that you collect for a study. A census, that involves collecting data from every member of the population. I like looking at censuses or censi, whatever the plural is for census, because they can be some pretty cool information. They usually collect those every 10 years. Next up, there's a parameter, and that is the numerical description of a particular population characteristic, and that's going to be a value we're going to use a lot. We're going to look at population parameters. And then there's a sample. Of course, that's a subset of a population. And then there's a sample statistic. That's a numerical description of a characteristic of a sample. And they summarize them all here. Let me see if I can raise this a little bit. So a population, that involves the whole group as opposed to the part of the group, which is a sample. With a population, it's the group that you want to know about, whereas a sample, you already know about the group. A population, the numerical descriptions of the characteristics, they call those parameters. And with a sample, they're numerical descriptions of characteristics called statistics. Your parameters are usually unknown for a population, whereas for a sample, your statistics are always known. Your parameters are fixed for a population versus your statistics vary for the sample chosen. Now, a representative sample is one that has the same relevant characteristics as a population, does not favor one group of the population over another. A random sample is one where every member has an equal chance of being selected. Now, a stratified sample is one where the members of your population are divided into two or more subgroups. You call them strata, that share similar characteristics like age or gender or ethnicity, and then you pick a random sample from each strata. And not to be confused with cluster samples, one chosen by dividing your population into these different groups called clusters that are each similar to the entire population. So, and then the researcher picks from these clusters. So I guess the difference between a strata and a cluster, with a cluster, suppose you're taking you divide up into different clusters of groups of people. So you just say, all right, there's a group of people here in a great big room of 500 people. You say, all right, everyone pick a number between 1 and 5. 1s, you're over here. 2s, you're over in this spot of the room. 3s, you're on this spot. 4s on this spot. 5 on this spot. And then from these different clusters, you then take a sample from each of those clusters, okay? As with a stratified, coming back to stratified, an example of that might be where you're looking at Fords, Chevrolets, Dodges, Toyotas, right? So from them, you've got all these different strata, and then you start picking from these groups to find out, I don't know, testing gas mileage or something on these different vehicles. But you're dividing them into different specific groups, okay? So with a stratified sample, you've got specific groups that you're picking from, whereas with a cluster, you're kind of randomizing your different clusters and then picking from them. I hope that makes sense of how I describe that. Sorry I don't have an actual visual here, but hopefully you're able to understand based on what I just said. Then a systematic sample, those are kind of cool. That's when you pick every nth member of the population. So say you're knocking on doors in a dorm, and you just knock on every 10th door. That's an example of a systematic sample. Finally, a convenience sample is one where the sample is convenient to select. For example, if you're looking for dinosaur fossil bones, that's going to be a convenient sample because you simply don't have any bones to pick from. All right, let's take a look at our homework now that we have these different definitions locked in. Just as a word of warning, this section can get a little tricky when it comes to the homework. So, in fact, I might even struggle a little bit as explaining this to you, but I hope I do it justice and we're going to be okay here. All right, so for this population parameter, we're going to look at are any of these actual studies that have been done where they collected the data versus it's more of a generalized population we're talking about. So our first one, in fact, I think this is our guy. 78% of the children diagnosed with cancer were in remission after 5 years, and this number is improving. I don't see any sample statistic happening in there, so I think that's going to be our guy. Let's look at the rest anyway, just to make sure. Yeah, of 300 dog owners who were surveyed, 70 reported owning dogs. That is totally a sample statistic there. As part of her senior project, Kaisa answered 84 of her classmates if they voted last presidential election. 39 said yes. Absolutely, that's a sample statistic as well. And this last one is going to be as well because of the 1,000 subjects on a study and multiple births, 38 gave birth to twins. That's a sample statistic as well. I'm sure we got this one right. And we do. Now this one, this is actually a little bit tricky, so I did this in advance to make sure. An EPA contractor needs to test the concentration of a substance in 10 samples in the groundwater. 70 samples are already collected from a single source over a week of regular intervals. And then the contractor wants to test samples evenly over the course of that time frame. So regular intervals, I think, is your giveaway. And these test samples collected evenly, those two words are kind of your flag words to show that, yeah, you're talking systematic sample. A sample in which every 10th member of this population is selected, by definition, we're talking systematic, right? So we got that one. Now I nailed this next one. 841 instructors at a local university were surveyed. 67 of them teach 2 or more classes. So we want to know if it's what the population is, what the sample is, and what the sample statistic is, or if it's a population parameter. So it's going to be, your population will be instructors at a local university, because it kind of tells you that. And we're going to have a sample of 841 of them that were surveyed, so that's our sample. That's easy enough. The tricky part might be to figure out whether it's a sample statistic or is it a population parameter. Well, we're taking a sample of that 841 instructors, so that's how I knew it was a sample statistic. So hopefully that'll help you guys out. Hopefully this one's going to be pretty straightforward as well. We wanted to figure out which of these is a sample statistic. So this first one, a poll of the entire student body found that 32% of the students at this college voted in the last presidential election. They don't tell us exactly what that sample is. So I think that's a population parameter. This next one, this Institute of Pediatric Dentistry reports that 42% of these students have at least one cavity. There's not an actual study done. That's more of a population parameter as well. And the next one, 78% of our children diagnosed with cancer are in remission after 5 years. Number is improving. Again, they don't give us an actual number. Now, this last one, of 351 dog owners who were surveyed, 70 of them reported owning dogs. That is our guy. I'm sure of it. And it is. This next guy I got right away. Soda Bottling Company will test the first 100 bottles on the production line to assure that it meets quality standards. So they tested the first 100 bottles. That right there is convenience, because they're like, yeah, I don't want to be here all day. I don't want to sit there and randomize this. Let's just take the first 100 bottles and call it good and go out and eat dinner or something. So yeah, it's convenience. At this point, you should be starting to see some of these problems, some of these examples come up to play again. So we want to find out the population parameter on this one. We probably have seen this one before in a earlier in this video. Kaisa asked 84 of her classmates if they voted in the last presidential election. 39 said yes. So they gave you the value there. That is a sample statistic. 15% of the attendees in a town council meeting responded to not using the internet. Well, it's a town council meeting. It's a small number of people, so that's going to be a sample statistic as well. Right here for this next one with the dog owners one, they talk about 70 owning 2 dogs. That's also a sample statistic, which leaves this guy. The study you've got where they talk about reproductive technology, looking at hospital records across the country. The report stated that an estimated 3.2% births of U.S. last year resulted in twins. That's definitely a population parameter because they don't give you a sample statistic at all. And it is. Speed things up a little bit here. We're looking at a sample statistic again. Now, I've already mentioned this a couple times in previous examples. The one with the town meeting, see, it just keeps coming up. That's going to be our guy. And it is. Again, speeding things up, we're looking for another sample statistic. It's going to be this guy because you've got 70 out of your 89 that reported being cancer-free. These other guys are population parameters. And this last one, they talk about every nth number getting selected. That is going to be systematic, and I believe we've got it. So when you guys get your homework, you might be challenged with some harder questions in this. If you keep getting hung up, just ask me if you get stuck. But if you click on trying similar problems, you'll start to see a pattern in things, and hopefully that's going to help you guys out. All right, good luck, guys.